For this particular problem, we can solve by any method we choose. I notice that both equations are in standard form since the x's and the y's are on the same side and all the constant terms are on the other side. So the elimination method would work well. How about if we go ahead and eliminate our x terms? To do that, if we multiply this top equation by 10, the x would turn into a 4. If we do that, then we could multiply the bottom equation here by negative 4 to make it so we have a 4x and a negative 4x. That would make it so the x's would eliminate when we add them. So let's go ahead and multiply the top equation by 10 and the bottom one by negative 4. Distributing the 10 through, we get 10 times 0.4x, which is 4x, and then 10 times the negative 2.5y, which is negative 25y, and then 10 times negative 6.5, which is negative 65. Now distributing our negative 4. Negative 4 times x is negative 4x. Negative 4 times y is negative 4y. And that equals negative 4 times 5.5, which is negative 22. If we now go ahead and add our equations together, the x's eliminate, we end up with a negative 29y equaling a negative 87. If we divide by negative 29 on both sides, the negative 29's will cancel. You're left with a y, and negative 87 divided by negative 29 is a positive 3. You can do that calculation in your calculator if you need to. Now we need to find our x value. So if we take this y value and we replace it in for y here in our bottom equation, we can easily find x. So we have x plus 3 equals 5.5. If we subtract 3 from both sides, subtracting 3 over here would cancel that out and leave us with an x. And subtracting 3 here, we get 2.5. So our x term is 2.5 and our y is 3. So the point where these two lines cross is the point 2.5, 3.